friends, today we'll be discussing about linked list, one of the data structure. In the last lecture we were talking about array, the sequential storage. There are many advantages of sequential storage. In array as a sequential storage, we can allocate a memory at a compile time. It means when we want to define some amount of memory, so we have already planned that we need some amount of memory, so that particular memory we can declare at the time of declaration with some data type. So this is known as compile time declaration of the memory. So before execution, whatever we declare or whatever we reserve as a memory for a usage in the programming, that is known as compile time memory allocation. This is reserved before execution. This memory, the array memory, is mostly referred with the indexing technique. 0 is the least indexed, whereas n-1 is the topmost index used in the array. So we can increment as well as decrement the indices. The index 0 will refer the first element in the array, whereas 1 will refer the data item stored on second location in the array. n-1 location will be defined as the data value stored on the last location in the array. So increment and decrement can be used for referring a data. Start and end of an index can be used to check upper and lower bound of the array. Sometimes if we want to store a data item into the array, and we should make sure that the array is not full, then we'll be checking whether n-1th element, 1-1th index and the respective space, memory space, is filled or not. If it is not, then we can understand, okay, this particular array has some amount of memory where the data item can be stored. This is how we can check the upper as well as the lower bound of the array. The memory is defined here. With a small example, we can understand how the array is stored in the memory. So ARY, name of an array, which is referred by a general user, an end user. The index is 0, then index 1, 2, and 3. The memory refers the addresses of the location. The ARY is stored at a location 2002. ARY1 is referred with 2003 address. ARY2 is referred with 2004, and so as ARY3 is referred with 2005. The value 20 is stored in array of index 0. This is referred with the address 2002. The same way, 3 value is stored on the address 2003 in the memory. So we know that these are the addresses and these are the array variables referred by an end user. So this is how we can store an array in a memory. In the right hand side, we can see that a memory is similar kind of memory exists. Sometimes whenever we want to store values in the memory location, we don't get a sequential storage. We don't get a sequential space to store an array. So in that case also, we will be able to store contents in the memory, but those contents are scattered. Like 13 is stored on 2001th location, whereas 07 is stored at 2004th location. 20 is stored on 2007th location, whereas 3 is stored at 2010 location. This is done in this kind of manner because continuous memory does not exist. That is why wherever space is available, we store a contents. So this particular storage is a scattered variables in the memory, but we are expecting a sequential storage. So for continuous sequential storage, how we can store? we just need to remember the addresses. So first, second, third and fourth. So we need to refer these addresses because these addresses will allow you to access the values in the memory like 13, 7, 20 and 3. So if we refer the addresses, we will be able to use the memory, the values in the memory. The linked data. If we want to link data, if we want to store the data in a proper manner, then we need to remember the values of that particular memory and the respective addresses. So if we want to store it in a proper way, what we need the address and the respective value. So we can have a structure in which we can store an address and a respective value with a structure of a object structure, and it's a object, say P of 4. So P of 0 will hold the address of first element, P of 1 will hold the address of second element, P of 2 will hold the address of third element, and P of 3 will hold the address and the respective value of the last element. But again, we are doing the same thing. We are using an array. The array is different. The array is a structure array. If we don't want to use a structure or an array, basically an array, then that particular memory can be defined only with the dynamic memory allocation method. So what we want these particular items to be sequentially stored in a one after another method. This is how we are expecting the storage in the memory, even though the addresses are scattered, not sequentially declared. This is how we can do it. What we have done here, the address of 20 is a 2007. Address of 30 is a 2010. Address of 7 is a 2004 and address of 13 is 2001. So address of this 3 is stored in with a 20 here. The address of 2004 is stored with 3 in this particular location. Address of 1 is referred in 2001 location with the 07 value. So this is how the address of 3 is stored here, address of 7 is stored here, address of 13 is stored here. So these addresses, if we have 20 and the address of next, so 20 and address of next is 2001, so that with this we can refer 3. 3 and the address of next will refer 0007 of a next value. 7 and address of next 2001 will refer the next value, and the 13 and the null means there is no further access or no further data value stored after 13. Then accessing 20, we need to refer the address 2007, and this 2007 will be stored separately with a new value or new element here, which has null value at the data and 2007 the address of 20. So this is how we can link up the data with the help of addresses. Then how can we do it in a practical way? In a practical way, what we have done, we have declared a structure, say struct student and integer star address. So star address is a address which will hold a pointer kind of variable which can hold an address and a value. So x, y, z, p are the variables. So x, y, z, p are the variables. So we have defined a null value at the start and a 2007 as an address, which will refer a x variable, x object. This x will hold 2010 address and will refer y. Y will refer 2004 the next address, and z will refer again 2001 the next address. So this is how the linking can be done. But this linking is not exactly the linked list what we are expecting. So what we can do, we will start understanding how the pointers and the structure objects will work. Then we will start writing a linked list program. So here a small example of a C programming code is written just to understand how the variables, the pointers and the object of a structure will behave. We have a structure here, struct student, which has an integer roll number, a integer pointer next, and an integer contact as another variable. So where we can store the value of a contact number of a person. So in a main, we have declared as variables, objects of a struct student data type. Struct student is now a data type of a structure. So pointer P is a pointer kind of variable of a structure, where K and R are normal structure objects. Since P is a pointer type of variable, so we have to declare a memory with the malloc function. So this malloc function will allocate memory of a size of struct student and hand over the control to P. Then we'll store a value P arrow roll number is equal to 10. Since P is a pointer type of object, we are supposed to use an arrow operator. So we have stored a 10 value into roll number. Then the same value is printed with a printf, say P arrow roll number. Then K dot roll number. K is not a pointer type of object of a structure. That is why we are using dot operator. And with the dot operator, K dot roll number is equal to 20. R dot roll number is equal to 35. Print F, K dot roll number will be printed so that K dot roll number will print 20. So this side in the memory, so we can understand that P is a pointer defined, whereas K has a roll number, something is defined here, next is a pointer, and contact is some value that can be stored, where R is an object. So this is how a memory can be defined, or memory can reserve a memory for a respective variables. So we have another program, a small C programming code to understand structure and the pointers related to that. So here we are trying to define an object of a structure. First of all, we will understand a structure. Struct student. In this structure, we are defining an integer roll number, then struct student pointer next. So this structure type of pointer is defined so that it will be able to point the next object in the list. So this particular next will hold the address of a forthcoming objects. So in this way, in the main, we have declared x dot roll number, y dot roll number, z dot roll number. X, y, z are a normal objects. That is why we are using a dot operator. So 20, 3 and 7 are stored in the roll number place in that particular object. Further, pointer P is a pointer type of object of a struct student structure. So that is why we have declared using malloc, and once the memory is reserved for P, then P will get a value 13 in the roll number. So we use a dot operator for A, X, Y, Z objects which are non-pointer type, and P will get an arrow operator which is of pointer type, and we can access the respective value and print it. Then we now will move towards the linked list. Till now we understood the dot operator, arrow operator, pointer kind of object, how to declare a memory for a pointer object of a structure, how to declare a structure. Now we'll try to link up 3 different objects in a linked list. So again the same structure, struct student, integer roll number, integer contact, two variable for storing data are declared. Then we have struct student next for storing a address of a next object. Then in the main we have declared three objects, say PQR. So this PQR will hold the object details further. PQR all are pointer kind of objects. That is why we have declared a memory for P here. So P will have to declare a memory with the malloc. The memory is declared. It is already discussed in the previous slide. So P will get a value, say 10. Then we are going to assign a contact number in P arrow contact as a 1111. Then these values are printed using arrow operator. So P arrow roll number, P arrow contact. Then P one more object, say Q, pointer Q has been declared. A memory is assigned with the malloc function. Then 20 and 2222 contains are allocated, assigned to Q roll number and Q contact. These two values are printed here with the printf function. Once this is printed, then now we want to assign a P and Q. We want to link up P and Q. So to link P and Q, how do we do it? P arrow next. Now next is a pointer kind of variable. The structure type of pointer variable which can hold the address of next object. That is why we say it like P next is equal to Q. Q is another object. So this particular line will link up P with Q. So whenever we say P next, that is Q. So that can be assigned like P arrow next is equal to Q. Then we will assign another object like R. R is again memory stored. A 30 value is assigned to that. 3333 is declared. Then we have to print the value R and R contact. This is done. Now we have to link up Q and R. So Q and R. So how to link up Q and R? Q is already declared, a variable object. Then Q next is equal to R. The same thing what we have done for P arrow next is equal to Q. We are doing the same. Q arrow next is equal to R. So this particular line will link up Q and R. So in the previous line we have done PQ. Now we have done QR. So this is how we have linked PQR in a list, linked list. So we will see the last 3 points, particular printf. These 3 printf will make us understand how they are linked with each other. In the first printf, P roll number and P contact number are directly declared. So P roll number will print 10, P contact number will print 1111. So the next printf will have P next roll number. So what we do? So P next roll number is 10, but P next roll number is P next is what? P next is already we know that P next is Q, and Q next roll number is 20. The same thing, it means P next roll number will print 20. Similarly, P next contact will print 2222. Then the last point, P next roll number. What is P next? P next is Q. This is what we have declared. And then Q next is, see, Q next. This is Q next. This is a Q next. Q next is Q next. Q next is already we defined like R. Q next is R. And R roll number is 30. So we will get P next P next roll number as a 30 and P next contact as a 3333. So this is how we get the final result. So this is how a single pointer P is able to access the contents of P roll number, P contact, then P next roll number, P next contact, P next roll number, P next contact. This is how we can, one single pointer is able to access all the details, because all those are linked in a linked list, and this is how we can access the variable. So I expect you to write this particular program and observe their behavior. Thank you. We have some applications of a linked list. So dynamic memory allocation is one of the application, more important application for a linked list, with which whenever we are executing a program and during execution we find that we are having a new object that to be declared and usable. So what we do, we'll define a memory with the malloc function at a runtime and can generate an object. So this object can be very easily visible in the program. Then implementation of other data structures like a linked list and stack and a doubly linked list can be executed using linked list method. Implementation graphs is also possible with the linked list. In fact, we have to use linked list for the same. Maintaining a dictionary of names will also help us to make use of linked list. Operations on long integers can be executed using linked list, whereas the last is representing sparse matrices can be executed using linked list. These are some of the applications of a linked list. Thank you.